So we're going to continue talking about cost functions, and we're sticking with linear cost functions for now. We'll get bigger as we go throughout the semester. So let's look at this. We have a plumbing problem, and we call a plumber to come out, and they tell us that they're going to charge us $125 just to show up, and then $85 for every hour that they repair whatever wrong. So let's start by constructing a cost function x for the number of hours of service that we need. After that, let's look at how much it'll cost if we have the plumber there for 2 hours. And then lastly, let's see how many hours was the plumber over if we get a bill for $805. Here, I'm assuming no parts needed, just they're going to fix something that's broken. So let's go back and start with just coming up with a cost function. So we're still talking about linear cost functions, mx plus b. So m is what's changing per hour, and that would be the $85, and then what's a flat fee, which is $125. So here is my function. C of x is 85x plus 125. Once I know this, once I know how to create the cost function where x is the number of hours, I simply plug in 2 if I want to know how much it costs to have the plumber over for 2 hours. I'm putting in 2 where the x was. 85 times 2 plus 125 says here's this big bill of $295 for 2 hours of work. If we get the bill and we're like, how long were you here? We could go backwards and say, well, I know that 805 would be 85x plus 125. I can subtract that 125 over, so now I have 6 to 80 is 85x. Divide by 85, and it says this is 8 hours of service. All right, let's look at a different idea, still doing linear, but let's talk about linear car depreciation. And if you want to read about this more, just this type of depreciation, it's called straight line depreciation, definitely used in businesses. Doesn't extend just to cars that I'm doing here, but also to like technology. Different things that will depreciate over time. You could do a linear, and they're looking at like how long are you going to use it. So there's like a useful life that's important here too if you would like to do some further reading. So here's the scenario I'm giving you. A company uses linear depreciation to value its company cars. Given the value of the car 2 years after purchase is $45,000 minus 5,625 t, I want you to find v of 0, v of 2, v of 4, and v of 8. And somehow I messed up this negative here. Sorry about that. I think I fixed it on the next screen. Okay, I did. So let's start with 0. 0 is like the initial value. It's how much was it worth when you first purchased the item. And so that says this car first purchased for the company was worth $45,000. 2 years later, after the car's been used for a while, it's down to $33,750. In 4 years, and again, I'm just assuming you know what I'm doing now. I'm plugging the number in, is $22,500, and very surprising that in 8 years it has a value of 0. Kind of shows you the limitations of linear depreciation. For a car, we don't really expect a car to be worth 0, but if you call that the useful life where you're going to have to justify buying a new car, usually we don't want to keep a car for 8 years, so we would trade it in, hope that it had some value, but this is just the model of linear depreciation, so I wanted to show it to you. All right. Let's look at cost function in a different direction where it's not so obvious. So let's say a company can manufacture 100 tires a day for a cost of $5,700, and the cost of making 200 tires a day is $10,200. So we're going to assume that the cost is linear, and I want to construct a function c of x for making x tires a day. So I still have the same idea that I want to be using mx plus b, but I have to start a little different. And so what you see that I posted here is, what do I know? I know that 100 tires, so I'm plugging in 100, should be m times 100 plus b, and that total cost is $5,700. If instead it was 200, I get $10,200. And just pointing out here, do you see how it's not twice the amount? Twice the amount would be bigger than that, so I see that something is going on. I can't just double and say, hey, here's what it is. But what I can do is I can kind of get rid of those c's from the beginning, write these two together, the m times 100 plus b and the m times 200 plus b. And here, let me show you really what I did, is I said, well, what if I were to subtract these two? Okay, so 100 minus 200 is negative 100m, and I just kind of swap these around because I like the way it looks better. The b's cancel, which is great, right? Every time I'm doing this elimination kind of thing, I can get rid of the b's. 5,700 minus 10,200 gives me negative 4,500. That's great, because now I can see if I divide by negative 100, since the tires are $45 each to make, there's my marginal, I can plug that back in, and I typically go to the first equation just because I see it first. Plug that in. This says 4,500 plus B is 5,700. So B is 1,200. There's my cost function. 45x plus 1,200 is the cost function for making these tires. Let's switch it over to something you guys like even more. Let's talk about pizza. So let's say a restaurant can make 20 pizzas for a cost of $580, and it'll be $820 if we make 80 pizzas. So let's figure out how much would it cost to buy 100 pizzas. Okay, again, let's assume it's linear. So this is going to feel really similar to the tire example that I just did, and I'm going to start us off with these equations. To say the cost 580 is for 20 pizzas, and the cost 820 was for 80 pizzas. And once again, you're going to see I subtracted. So 580 minus 820 is negative 240. 20 minus 80 is negative 60. And again, I move that m to the right. And one more time, the b's canceled out. Divide by negative 60. So now I have the cost per pizza is $4. That sounds about right. And then I have some kind of fixed cost. So if I put the 20 in, 20 times 40 is 80. That says the b is 500. So this said the cost it would make them to make 100, I would put 100 in. 100 times 4, 400, plus 500 is 900. Okay. Sticking to cost, switching over now to a vending machine. Just trying to pick up things that you guys are familiar with, you see every day. So I looked up online because I knew nothing about vending machines really, and I saw that most of the time they're about $3,000 to $5,000 to purchase one. So I said, what if we go somewhere close to the middle of that? And I said, let's go with $3,800. And then I thought, well, let's look up about cans, how much we could buy them close to wholesale, 25 cents. So I want to construct a linear cost function where if we're this vendor and we bought this machine and we're selling sodas, how much are we paying? How much is our cost? So our cost is 0.25x plus 3,800, where x is the number of cans of soda that we're purchasing to put in the machine. All right, so let's talk about a new concept, which is average cost. An average cost is I take the cost and I divide by how many items I sold. So here I have my cost function, my normal cost function, I divide by x. So here's my 0.25x plus 3,800, the cost for the vending machine, and divide by x, the number of cans that we bought. So I'm going to plug this, and I actually put this into my graphing calculator. If you do put it into your graphing calculator and use the table, really important that you would put parentheses around it when you do it so that you get the right answer. And I show you all the values that I got. So it says if I buy one can, it costs me $3,825. That's crazy. If I buy 100 cans, on average, I spent $38.25. Again, way too much. 500 is $7.85. 2,000 is $2.15. By the time I get to 5,000 cans purchased, I spent $1.01 on each. 15,000 says I spent about 50 cents a piece, and 25,000 says I'm close to 40 cents each. So what I want you to see here is the average cost decreases as we buy more cans of soda. As it decreases, I know it's very natural for you to think, well, it's going down to zero. That's never going to happen. The cans of soda were never free. We were always paying that 25 cents per can. What's happening is the more that we bought cans of soda, we're kind of disappearing that initial big value of $3,800 that we had to pay to buy the vending machine. Okay. So we need to start making some money, right? We bought this machine, we're spending money on the cans, we need to bring some money in to pay for this thing and get some profit. So the first step in talking about that is revenue. So we have to charge a price for these cans of soda. And so let's say a typical price would be 75 cents. So let's construct our revenue function. Really important to know that revenue is price times quantity, and if you just want to have variables, it would be little p times little x. So for our particular case, I have 0.75x, so here's my revenue. Okay. Revenue is interesting, but what's more interesting is profit. Profit is always revenue minus cost. Really, really important you put revenue first and make sure you're using parentheses where they belong, and you'll see that when I put mine in, that this revenue I had was 0.75x, and I put parentheses around the whole cost function of 0.25x plus 3,800 because I want to make sure I distribute that negative all the way through the cost function. I can combine like terms there, so this 0.75 can go along with this negative 0.25 to give me 0.5x, and this negative distributes over the 3,800 to give me negative 3,800. Again, let's look at some values for that. So I'm going to keep that equation I just had, and I'm going to plug in 0, 2,500, 5,000, 10,000, 20,000 to see, am I making any money? So at 0, of course, I made no money. All I did was buy a machine and I didn't sell anything. If I sell 2,500 cans of soda, I am still in the hole. I still have not received as much money as I've spent. Same thing at 5,000. But you can see here at 10,000, hey, I made some money. I'm at 1,200. And at 20,000, I'm up to 6,200. So that's good news. It's a good news, bad news. Good news, yes, you can make money, but bad news is, wow, it's going to take a while. Unless this is in a place that sells a lot of cans, and you better be there to restock it all the time. So let's talk about how long, not how long, but when am I going to break even, right? How many cans of soda do you have to sell before you at least hit 0? And the 0 is that break-even point. I want to know, when does the cost equal the revenue? This is the same as the profit being equal to 0. So here's my revenue, 0.75x. Here's my cost, 0.25x plus 3,800. I'm going to move all the x's to the left, so now I have 0.5x. That says that's 3,800, and when I divide by 0.5, I get 7,600. So I need to sell 7,600 cans of soda to kind of pay off the machine and pay off everything I bought. But that says that next one I sell, 7,601, I'm going to make some money, and that's good news. All right, last thing to look at, I just wanted to go back to the average cost again, is a gym membership. All right, so I took this from the internet somewhere. I don't remember what gym it is. Sorry about that. But it shows you some plans, and I'm going to go with this first plan that says we can go to a bunch of clubs. So it says there's an $89 initiation sign-up fee, and then you're going to pay $29.99 a month. So I want to look at the average cost of joining this gym and over a number of months. So I'm going to start with, oh, this came out crazy. The average cost function is $29.99 times x, the x is the number of months, plus 89, and I'm going to divide by x. So this will tell me how much I've paid per month, depending on how long I keep the membership. So if I sign up and keep the membership for 1 month, it means I'm going to pay $118.89 for that 1 month. That's a bad idea. Let's stay longer. So if we stay for 2 months, so we paid that $29.99 twice, plus the $89 to sign up, we divide it by 2, and it says it's $74.49. Again, really expensive, so let's stay longer. If I put in 4, I got $52.24. At 6 months, we're down to $44.82. After a year, it comes out to $34.41. So let's look at 2 years, drops down to $33.70, and finally I put 4 years, which was $31.84. Again, as we see, this average cost should be decreasing as we look at average cost functions. And just like we talked about earlier with looking at how things drop down, like I was looking at the cans of soda and it was getting cheaper, it was headed toward that 0.25 for the cans of soda. This is headed towards this $29.99 a month, which is what our monthly fee is. This initiation fee kind of gets spread out the more we look at it, and it averages out, so we feel better about our purchase. All right, that's the end of this video.